Assalamu alaikum. Hope you are doing good. Let's start with today's video lecture. We are going to review formulas and functions, and as I have already discussed this in class, it's a very easy topic, and basically you have a given expression and there are unknown quantities in those given expression. You have 3-4 variables, you have values, you plug the values in the formula, and you have one unknown. You make unknown the subject and find that unknown. That's what you have to do in formulas. And the next thing in formulas is basically the strange formulas, and in these formulas, as you can see over here, x heart y, that's heart is not a very trivial symbol. It's not a symbol of addition or subtraction or multiplication or division, which you already know from your past experience. It's a user defined formula. It's defined in the question. So for example, over here when you see x heart y, this means that the first term square added to the last term square subtract from these two terms the product of those two numbers. So for example, 2 heart 3 means 2 square 4, 3 square 9. You add these two numbers, 4 plus 9, that's 13, and you subtract the product of, so 13 minus 3, 2 into 3, which is 6, so that's 7. So 2 heart 3 is 7. And that's how user defined formulas are. These are strange looking formulas. Whatever the formulas are, the definition of the formula will be given in the question. It will be defined in the question. Okay, moving on. Okay, formulas with unspecified amounts. Basically, these are questions in which there are some quantities, and those quantities are in terms of fractions. There is no number, there is no hardcore number, there are no hardcore values. So in these kind of examples, in these kind of questions, what you have to do is you have to pick some numbers. For example, let's see this example. Length of a cube decreases by 2/3 of its original value. By what percentage will the volume of the cube decreases? So you just pick up a number. Let's say for example, you pick a number, the side of the cube is 3. So by this assumption, the volume of the cube will be 3 cube, which is 27. Okay? And now it's given in the question that 2/3 of its length decreases. So what's 2/3 of 3? That's 2, right? 2/3 of 3 is 2. So original length was 3 and it's reduced by 2/3 of 3, which is 2. So the new length is 1. So this means that the new volume is 1 cube, which is 1 cube 1. Okay? And the change in volume will be 27 minus 1. So that's 26. So 26 is the change. The original volume was 27. So 26 upon 27 into 100. That's the percentage which the question is asking. Okay, I hope you understand this. And now moving on to sequence formulas, and we discussed these sequence formulas in pretty much detail in our class. And as you can see, these two formulas are basically formulas in which you just plug the number and you will have that term of the sequence. For example, let's say I put 5 in this, so I will get the 5th term of the sequence. But not all sequence formulas are like this. You might have seen formulas like this. These are recursive relationship formulas, and in these formulas, let's say for example, if you want to find the 5th term, the 5th term depends on the 4th term, and the 4th term depends on the 3rd term. The 3rd term depends on second on 1st. And usually in these kind of formulas, some initial conditions are given. Some of the famous recursive formulas are Fibonacci sequence, and you can see in Fibonacci sequence, the first two terms are given 1 and 1, and the next consecutive terms are basically the addition of the previous two terms, and that's how the terms of the Fibonacci sequence are created. Moving on. Moving on to functions, and as you can see over here, function is any expression like this, f of x and g of x. This is the function of x, this is the function of t. And what you need to know about function is that how to compute a value of function at a particular point. So for example, if I say I want you to find what is f of 5, so you just plug 5 in this expression and you simplify, and that's how you get your answer. So the function is x square minus 2, you substitute 5 in this, you get 5 square, which is 25, 25 minus 2, 23, 23 is your answer. Okay? And that was a numerical substitution. You substituted a numerical value in the variable. You can also do variable substitution in function, and for example, this is your function f of z, and in place of z you need to substitute w plus 6. So you substitute w plus 6 in place of z, and then rest is simplification, and finally you get your answer. Okay, and this is it. There's one more thing in the composite functions, and that's the last thing, and then we are going to wrap up this video. In composite functions, what you need to understand is you need to solve the brackets first. That's the key. So for example, let's say if I have two functions f of x and g of x, and I need to compute let's say f of g of 3. So first I need to compute g of 3, and in order to compute g of 3, I just need to substitute 3 in this function. I have g of 3 as 9, and now in place of g of 3 I just write 9. So now I have to compute f of 9, and when I do, then that's done. Okay, thank you. See you in the next video.